All right, we're going to talk about how to add complex numbers. And this is probably one of the easiest things that you will do if you're in an Algebra 2 class. So basically the idea here is that you're going to add the real parts and then add the imaginary parts, and that's about it. So like we said in the intro video on imaginary and complex numbers, what's amazing about complex numbers is that they form a system that's closed under addition, which means if you have a complex number and you add a complex number to it, you get a complex number. Okay, so I'm going to take the real parts. So the real parts here, I'm going to do color code in orange. So that's not orange. There we go. That's orange. A is a real number and C is a real number. Okay. I know that B and D are real numbers. Hey, C, where'd you go? B and D are real numbers, but they're multiplying the imaginary number. So I consider the BI and the DI the imaginary part. So when you take the real parts and add them, you'll get A plus C So that's kind of the real part. And then the imaginary part here will be whatever B, and I apologize, I put C in the wrong color there. So C is yellow. And then the imaginary parts together, how many I's will I have? Well, whatever B plus D is, that's how many I's we'll have. So this is the generic answer, which looks kind of complicated, and I know I said that this would be one of the easiest things you've done. I promise it will be easy. Okay, and so we'll color code this for the imaginary parts. So the imaginary parts, I'm considering BI and DI, the imaginary parts. Okay, all right, let's scroll down and look at some examples. So that was kind of generic, which makes it a little complex. Pun intended. Okay, so on this one, you've got 2 plus 3i and 4 plus 7i. Quite literally, this is just going to be 2 plus 4 is 6, and then 3i plus 7i is 10i. Notice how we started with two complex numbers, and we finish with a complex number, 6 plus 10i. Okay, that's it. That's all you have to do for these. How about 6 minus 2i plus 3i minus 3? Some of you are going to say that's not a complex number, and I say, sure it is. It's got a real part, negative 3, and then it's got an imaginary part, plus 3i. Sometimes they're written differently, but it's still a complex number. All right, so if you take the real parts, so if you take 6 and negative 3, that gives you 3. And if you take negative 2i plus 3i, that gives you plus 1i. I'm just going to write plus I there. Okay, how about this one? So negative 6 minus 3i and plus 4 minus 3i. So let's take the real parts first. So we have negative 6 plus 4. That's going to give us negative 2. And then we've got negative 3i plus 3i. So that's plus 0i. Plus 0i. We don't really need to write the 0i, but we can. Okay, I usually don't include it, so I would just put as my final answer there. I would put negative 2. And negative 2 is a complex number because it's negative 2, that's the real part, plus 0i, that's the complex part. Okay, last one here. So we've got 6i, which again might not look like a complex number because it doesn't have the a plus bi form to it, but it actually is because it's 0 plus 6i. So if we add the zero parts, if we add the real parts, that would be a 0 over here and a minus 7 here. So 0 minus 7 is negative 7. And then if we add the imaginary parts, we get 6i plus 2i. That's going to be 8i. So that would be the answer for that one. And that's how you add complex numbers.